Welcome back to chemistry class. Today's topic is the mole. Grab a pen and your notebook. We are going to start shortly. When we say mole is equal to 6.02 times 10 raised to the power 23 count. Let me explain. What does it mean? We already have covered stoichiometry in the previous video. What is stoichiometry? Just recall the study of the quantitative aspects of chemical reactions. Stoichiometry means to determine how many atoms, how many molecules are participating in a chemical reaction, how much do they weigh. The mole is a counting unit. Similar, we count dozen. In dozen we count is 12. In mole we count is like 602 billion trillion. In scientific notation we can write 6.02 times 10^23, and this number is named in honor of Amedeo Avogadro, who studied and discovered that no matter what the gas was, there were the same number of molecules present. We will be using different terms for this 6.02 times 10^23. They may be molecules, they may be atoms, they may be particles. One more time. 1 mole is equal to 6.02 times 10 raised to the power 23 molecules. Regardless, what is this? 1 mole of apple, that many particles. 1 mole of carbon, that many particles. You don't need even periodic table for this. Let's proceed. How big is a mole? Enough soft drinks cans to cover the surface of the earth to a depth of over 200 million. You can imagine how big is the mole, because it is 6.02 times 10^23. So it means billion trillion. So if you had Avogadro's number of unpopped popcorn kernels and spread them across the United States of America, the country would be covered in popcorn to a depth of over 9 miles. So how big is this mole is? If we were able to count atoms at the rate of 10 million per second, it would take about 2 billion years to count the atoms in 1 mole. Where does this Avogadro's number come from? It was not just picked, it was measured. One of the better methods of measuring this number was the Millikan oil drop experiment. Recall atomic structure, where we had talked about discovery of electron proton. Since then we have found even better ways of measuring using X-ray technology. How this number was derived, you can understand if you connect by that lesson, atomic structure. Suppose we invented a new collection unit called a wrap. One wrap contains 8 objects. How many paper clips in one wrap? We know one wrap always contains 8. So what is the right answer? C. How many oranges in 2 wraps? 2 wraps. 1 wrap equal to 8. So 2 wraps, 2 times 8, 16. How many wraps contain 40 gummy bears? 40. So 8 objects makes 1 wrap. 40 would make what? 40 divided by 8, it would be what? 5. The mole. What is mole? Excuse me. Like 1 dozen cookies. How many cookies? 12 cookies. 1 mole of cookies? That many cookies. 6.22 times 10, 23. 1 dozen car? 12 cars. 1 mole of cars? 6.22 times 10, 23 cars. 1 dozen aluminum atoms? 12 aluminum atoms. 1 mole of aluminum atoms? Al is a symbol of aluminum. 6.22 times 10, 23 atoms. Note that the number is always the same. Mass is very different. So if you are looking for mass, you need periodic table. But if you want to know the number of atoms, you don't need. So number is always the same. 1 mole of car, 1 mole of cookies, 1 mole of aluminum, 1 mole of sodium, 1 mole of carbon equal to this number. But what is their mass? Aluminum mass is different, cars mass is different, cookies mass is different, sodium mass is different, carbon mass is different. One mole of carbon, how many particles? Go ahead. 6.02 times 1023. 1 mole of H2O. Again. 1 mole of NaCl. See, we have used atoms, molecules. Since NaCl are the ions, for ions we use another word. What? Formula unit. Six 6.22 times 10 raised to the power 23 of sodium ions and 6.22 times. See, 1 mole. Their masses, mass of carbon, mass of H2O, mass of NaCl is different. But number of particles, number of atoms. See here, particles, atoms, molecules, formula unit is still the same. Remember that. Don't forget, please. Let's move. Avogadro's number as conversion factor. So 1 mole of anything contains that many particles. So conversion factor depends on the format of the questions. Learning check. 0.500 mole of Al. How we find? What is the conversion factor we will be using? Let me show you. 0.500 mole. We have already done stoichiometry. Given unit is mol. What are we finding? Number of atoms at the top. 1 mole is 6.02 times 10, 23. Mole cancel out, but we got 0.500 times 6.02 times 10, 23. If we multiply what we get, use your calculator. You can use TI-83 to get accurate result. So what we get, C. That is the correct answer. Okay? Any question, you please don't hesitate to ask in the comment section. Number of mole of S in 1.8 times 10 raised to the power 24. Again, same method. 1.8 times 10, 24 S atoms. This time atoms have been given, so atom is the denominator and top 1 mole. So 1 mole always have 6.22 times 1023. Atom cancelled. 1.8 times 1024 times 1, so it should be 1.8 times 1024 divided by 6.02 times 1023. Put this number in your calculator and you will get the answer. So what is that? We know if you are using TI-83, you will get the answer. But if you are not, you don't have that type of calculator, let me explain. 1.8, just put this number in your calculator, 1.8 and 6.02. So you will get what? 0.30. 24, 23. So when we divide, these powers are subtracted. 24 minus 23 be 10, 1. So multiply. So this decimal move over here. So then this will go away and our answer is 3 mole. So our answer is B. This simple calculation. Okay. So that way we calculate 1 mole. So if you are given mass in gram, first you calculate moles and then you go to atoms. Okay, let's continue. Molar mass, the mass of 1 mole in gram. How you find the mass of 1 mole in gram? 1 mole of carbon. Check periodic table, 12.011 gram. Okay, let's see some more examples. Numerical value of the average atomic mass get from periodic table. Like I took 12 for the carbon from periodic table. So if we round it, 12.0 gram. 1 mole of Mg atom from periodic table, 24.3 gram. Copper, 63.5. Other name related to molar mass. Molecular mass, molecular weight. If it is a compound, we use formula mass, formula weight. If you have single molecule, then we use AMU, atomic mass unit. But the molecule is the same numerical value as 1 mole of molecule. Only the units are different. This is the beauty of Avogadro's number. Formula mass, same goes for compounds, but again, the numerical value is the same. Only the units are different. Okay? So again, keep in mind that you would be hearing different terms: particles, atoms, molecules, formula unit, molecular mass, molecular weight, formula mass, formula weight. All are same thing. Okay? Find the molar mass. 1 mole of Br. Br is what? Bromine. Check your periodic table. So what is the molar mass of bromine? Do you have periodic? I hope you have already solved. If not, let me help you. Bromine molar mass is 79.904 gram. 1 mole of Sn atoms. What is Sn? Is 10 and its molar mass is 118.710 gram. They say 10th place. So bromine would be 79.90 and Sn would be 118.71 gram. Let's move. Mass in gram of 1 mole equal numerically to the sum of the atomic masses. That's formula mass, CaCl2. First thing is Ca. So check periodic table. Ca is 40.1. Cl2. So Cl and there is a little 2. So Cl mass from the periodic table is 35.45. We rounded it off to 35.5, multiply by 2, it becomes what? 71. So 71 here and 40.1 over here. When you add, you got 101.1 gram per mole. N2O4. What's the molar mass of N2O4? First find nitrogen. Nitrogen mass is 14.006. 14.006 times 2. Oxygen mass is 15.999. So 15.999 and O4 multiply by 4. So what's the answer? So 14.006 times 2, we got 28.012 and 15.999 times 4 becomes 63.996. So it becomes what? 92.008 gram per mole. We round it off, 92.0 gram per mole. Okay, let's go. Molar mass of K2O. Try this one by yourself. Let me show this one. Al. Periodic table. Al mass is 26.98. I would round it off to 27 grams. OH. So first O. And O and H both are in parentheses. So oxygen mass is 15.99. I would round it off 16 and multiply by 3. So it should be 48. H is 1.007. I round it off to 1 and there's 3. So 27 plus 48 plus 40 plus 3. So we'll just add them up. 78 gram per mole. This I'm leaving for you. Try yourself and write your answer in the comment section. Second one also I have solved it, though I expect you try yourself first before you see our answer. Prozac C17 H18 F3 NO is widely used antidepressant that inhibits the uptake of serotonin by the brain. Find its molar mass. C17 H18 F3 and no number, so it's 1 and O1. Use periodic table. Molar mass of carbon. We round it off. So carbon mass is 12 times 17. Hydrogen mass is 1 times 18. Fluorine F mass is 19 and there are 3 atoms. Nitrogen is 14 times 1. Oxygen is 16 times 1. Now calculate 12 times 17. What we got? 204. 1 times 18 is 18. 19 times 3, 57. 14 times 1, 14. 16 times 1 is 16. Add all these numbers. 204 plus 18 plus 57 plus 14 plus 16. Your answer is 309 gram per mole. That's way we calculate the molar mass. Calculation with molar mass. Grams, molar mass to mole. Aluminum is often used for the structure of lightweight bicycle frame. How many grams of aluminum are in 3 moles of Al? So, factor label method, 3 mole, conversion factor, this mole, so mole go denominator, and we are finding what? How many grams? So gram, 1 mole is 27 gram. We round it off. So mole cancel out, 27 times 3. So what is it? 81 gram. Let's molar mass of Al. Okay. One more time, you can see and you can copy, you can take picture, whatever you want to. The sweet formula is used to sweeten diet food, coffee and soft drinks. How many moles of aspartame are present in 225 gram of? Okay. Try this one before you see our solution. Pause the video over here for 3 minutes and solve it, then come back. We will be helping you. Okay, see. First of all, calculate the molar mass of this. So carbon mass is 12 times 14. I rounded it off. 12 times 14. Hydrogen is 1 times 18. Nitrogen is 14 times 2. 28. Oxygen is 16 times 5. 80. Add them up, so you will get 294 gram. What has been given? The gram. So 225 grams times conversion factor, this unit would be as denominator at the bottom, 1 mole. Gram cancel out, 225 times 1, 225, 294, and we got what? 0.77 mole. Okay? Do all this calculation like we have solved. Okay. Atoms, molecules and grams. Since 6.02 times 1023 particles equal to 1 mole and 1 mole is equal to molar mass, you can convert atoms to moles. See, this is the first step. Convert atom into mole first, then into gram. You can't go directly from atoms to gram. You always go through moles. That's like asking 2 dozen cookies weigh how many ounces? 1 cookie weighs 4 ounces. So you cannot find out until you know how many dozen. You convert them into dozen, then because your rate has been given in dozen. Okay? Everything must go through moles. So write it down, this line somewhere. You will never do mistake if you remember this. How many atoms of copper are present in 35.4 gram? How many atoms? We cannot go from gram to atom, but we need to convert into mole. 35.4 gram of copper. Conversion factor, mole and gram, 1 mole of copper. Check your periodic table. It's 63.546. I would say 63.54. After that, this mole, now this is at the bottom. 1 mole of how many atoms? 6.02 times 1023. Gram cancel, mole cancel. So what we got? 35.4 times, this is 1, this is 6.02 times 1023 divided by 63.54. Solve that way and write your answer in the comment section. I have set up the question for you and leaving for you to solve it. If you need help, let us know in the comment section. But don't forget to write your answer in the comment section. I would like to see how much you got from today's video. 3.4 times 23 atoms. See you. First step, calculate the molar mass of this 6C6H12O6. You got 180 gram. Start from here, what has been given. This unit would be at the denominator, at the bottom. Set up this and you will get this. Write your answer in the comment section. I want to see if you have done correctly. So you cannot go molecules into mass until you change into mole. Let me write down one more time. 1.20 times 1024. These are molecules. And these are molecule. 1 mole. And then 1 mole. Find the molar mass of this, 180. So this is cancel out. Then multiply this by this and divide by this. Okay? Okay, let's move. How many atoms of O are present in 78.1 gram? So start from 78.1 gram and then gram unit at the bottom, 1 mole, then molecules and then atoms. See, we always go through moles. So the answer is yeah. Okay. What is the percent carbon in C5H8NO4, the glutamic acid used to make MSG, monosodium glutamate, a compound used to flavor foods and tenderize meat? Percent of carbon. How we calculate? Let me show you. C5. Carbon mass is 12. 12 times 5 equal to what? 60. Hydrogen 8. Hydrogen mass is 1. 8. So it should be 8. And mass of N is 14. No number, so 14 times 1 is 14. Oxygen mass is 16. And how many oxygen? 4. So 16 times 4 is 64. Actually, this is 4 times 16. Add all these numbers, 68, 14, 64. What do you got? 60 plus 8 plus 14 plus 64. You got 146. So molar mass is 146. Carbon mass is 60. So 60 divided by 146 times 100. What we got? 41.1. So this is the right answer. So that's all for the day. Thank you so much. Have a wonderful day.